Hi, this is the first in a series of short videos I'm going to try to do to complement the lectures that are about meshes in applied computer graphics. What I have here is Qt Creator with a simple project. The project file has all the settings that describe how this is going to be built. Template is app, meaning it's going to be an executable. Config, so Qt tries to have prepackaged cross-platform ways to do things. So if it knows how to do it in a cross-platform way, you can just add it to the config. So we're going to generate a console application. We're going to see the little black screen with the text. We aren't using the Qt extra Qt libraries that it has. We're just using Qmake as a compiler, so we'll remove that from the config. And we're just using Qt as an IDE development tool. We are using OpenGL, so Qmake, the build tool for Qt, knows how to set things up for OpenGL in a cross-platform way. We're using Glut for the user interface, and Qt doesn't know how to do anything with Glut, but we already set up, and we discussed it in class, putting all the libraries and header files in the right spot. The way that I happen to set it up, the library that I installed was called freeglut or libfreeglut.a or something. So in order to link with that library, I say libs plus equals -l freeglut. Okay, sources, this is automatically added by Qt Creator whenever I add a file. So in main.c, I've included glut.h, and I included it before gl.h. And if everything has been set up properly, if I press Control B, it builds without errors, but it doesn't show anything interesting. So in this video, we're going to get sort of the basic shell beginning of a program going. So we need to have a function to display. And I'm just going to GL clear the color buffer bit and the depth buffer bit. And then I'm going to do a glut solid teapot so that I have something to see. And this is a function that draws the teapot. It takes the size of the teapot. I'm going to use double buffering. So I'm going to swap buffers. So double buffering means everything gets rendered off screen. And then after everything is drawn, I flip that back buffer to the front so that the user can see it, and that prevents the user from seeing partially drawn frames in a game or a video. So that's my display function. To actually use it, I first need to initialize glut, and I need to pass in an argument vector. So in main, I can take in the argument count and the argument vector, which is a list of strings. Char stars are strings in C. And we'll just use argv. These double brackets mean that this is an array. I could just as well have said char star. And I could have done a double star to indicate a pointer to char. Whatever you think is clear. So glut init actually takes those two parameters. It's going to modify argc, so it takes the address of the argument counter. And it takes the argument vector. Since it's already a pointer, it can be modified. Once I've initialized glut, so we don't need to worry about what that does too much, it just sets some settings. I need to set the display mode to describe the way pixels, the information that's kept with each pixel. So each pixel is each dot on the screen. So for every single dot, I want to keep red, green, blue, and alpha. And I also want to keep the depth information so that I can actually test each pixel to see whether it's closer than what was drawn already. And also for each pixel, I want to keep an off-screen pixel that I draw to first, and then I flip it with the on-screen pixel later so that I can render in this invisible back buffer and then swap to the front. So I say double. Just saying that I'm using double buffering. So that tells me what data is being kept kind of with each pixel. Once I've done that, I'm ready to create a window, and I'm just going to call it Hello Applied Computer Graphics. And you notice that that function is really a macro. You could see it when I typed the parenthesis. It's called glut create window add exit hack. What happens is in a glut program, in order to actually run the program, well, first I need to specify a callback. So this is a function, this one up here, that gets called every time the window needs to be drawn. But then in order to actually start this loop where glut is constantly checking to see what the user does and checking to see whether the window needs to be drawn, etc., we need to call glut main loop, and it never returns. So this line right here will never get executed. This is a sort of a wasted line. Whoa, excuse me. This is sort of a wasted line. If we want to do something to clean up, which we're going to need to do later on, we need to do it by specifying a callback. So we'll do a callback called cleanup. That gives us the opportunity to clean up. And before main loop, we'll say add exit cleanup. Sorry, caps lock was on. Cleanup. So we pass that function pointer. So if I build, it tells me about a typo, and I build again, we're good. If I run this, I see that white teapot, so we're golden.